So this was last week homework, SI quantities, graphs, and motion. The first doubt is pay question 15, and then 41, and then the last two pages. Okay. So this one is question 15. You have to explain the motion of a skydiver. As you can see, the skydiver jumps from an airplane and and accelerate until she reaches a terminal velocity. So when she reaches a terminal velocity means that because initially what happened when the skydiver jumps, the initial acceleration is due to gravity. And weight is the only force initially that is acting. Then what happened is the speed as it is accelerating, so speed increase. So as a result, when the speed increase, the air resistance will also increase. So the resultant force, because the resultant here will be weight minus the air resistance, so the resultant force will decrease. As a result, when the resultant force will decrease, the acceleration will also decrease. And eventually, still it is accelerating, so still speed will increase. And eventually, the weight and air resistance are balanced. So when weight and air resistance are balanced, there is no resultant force. If the resultant force is zero, it does not accelerate, or it will move at a constant speed. So that's why you can see, like when she jumps, she's having her maximum acceleration. Then the air resistance start to increase. Air resistance try to oppose the motion. As a result, the acceleration resultant force decrease, the acceleration decrease. Eventually, what happened? She reaches no acceleration point, means that the speed is not changing. If the speed is not changing, means she's moving at a constant speed, or acceleration is equals to zero. Then what happened? She opens the parachute. So the moment she opens the parachute, her weight is acting downward, but when she opens the parachute, there is more air resistance. So when there's more air resistance, so now there is a resultant force, but the resultant force is opposite to the direction of the motion. The motion is downward and the resultant force is upward. So the direction of the motion and resultant force are opposite. That's why she will decelerate. So you can see that she decelerate, like the negative acceleration, or we can also say deceleration. Then deceleration also decreases. Why the deceleration decrease? Because as she decelerate, her speed decreases. When the speed decreases, the air resistance will also decrease. So when the air resistance decreases, eventually what happens? The air resistance balance with the weight again. Why at this point the deceleration is decreasing? Because her speed decreases. When speed decreases, the air resistance also decrease, so the resultant force is decreasing. That's why her deceleration is decreasing. And eventually, again, the air resistance balance with the weight, so she moves at a constant speed or no acceleration. So this is acceleration time graph. Normally, for a skydivers, what they provide a speed time or a velocity time graph. So this is actually the velocity. If we sketch a velocity time graph for this, so for a skydiver, when we sketch a velocity time graph, initially she's having a constant or a maximum acceleration. Then the acceleration start to decrease, the slope will decrease, and then she moves at a constant speed or no acceleration. So if I label the points, this is her initial acceleration. So this is her initial acceleration, which is initially it's a maximum value. Then what happened? Because the air resistance, as the speed increase, the air resistance will also increase. So her acceleration start to decrease. So acceleration is decreasing. So this part would happen as acceleration is decreasing because the air resistance increase. Then eventually what happened? The air resistance balance with the weight. So as air resistance balance with the weight, so she will not accelerate, or her acceleration will be zero. She will move at a constant speed, but acceleration is zero. Then the moment she opened the parachute, her deceleration will increase because the moment she opens the parachute, air resistance is more than the weight, so the deceleration will be more. As a result, like this is a maximum deceleration. Then the deceleration start to decrease as well, like this part is having a deceleration, and then the deceleration decrease. Why the deceleration decrease? Because her speed is decreasing. So air resistance decrease, so deceleration decreases. And eventually, again, the air resistance balance with the weight. So air resistance balance with the weight. So she will move at a constant speed. The difference between the two constant speeds here, the terminal speeds, that initially she was having a higher terminal speed without a parachute, but with parachute she will have a lower terminal speed. So you have to mention these points whenever you're explaining the motion of a skydiver or a paratrooper. Initially, the maximum acceleration, then the acceleration decrease, then there's no acceleration as the air resistance balances with the weight. And eventually, when she opened or a paratrooper opened the parachute, the air resistance is more than the weight, so it will decelerate. And even the deceleration decreases. Why the deceleration decrease? Because the speed is decreasing. As a result, the deceleration will also decrease. So consider a parachutist from jumping from the aircraft. So first, initially, the paratrooper or parachutist, the weight is acting downward. Then what happened? As he is moving, his speed increases, so air resistance will also increase. But still, he will accelerate because there is a resultant force downward. Then the weight balances with the air resistance. So this moment there is no air resistance. This moment there is no resultant force, so he will move at a terminal speed. Then the moment he opened the parachute, air resistance is more than the weight, so he will decelerate, and then air resistance will decrease because the speed is decreasing. And again, reach a new terminal velocity, which will be a lower terminal velocity. So this is a graph. First, speed is increasing, then acceleration is decreasing, then there is no acceleration or a terminal speed. The moment he opens the parachute, he slows down, so decelerate, and he will reach a new terminal velocity. The next one is question 41. So 17 and 18 are the last two pages. Okay. So question 41. In this experiment, a student released a small steel ball in front of a meter rule. So there's a meter rule or a meter scale is there. And student release a steel ball in front of that. For example, we have a steel ball and that is next to a meter rule or a meter scale, and uses a video camera to record the motion. So there's a camera placed here which is recording the motion of this sphere or a ball. And the camera captures 30 images every second. Like in 1 second, there are 30 frames or 30 images are there, which may be playback. So we can also play back those. Explain how the acceleration of a free fall could be determined using the recording. So how we can work out the acceleration? For falling objects, always remember the initial velocity is 0. And using the camera, we can determine the time. And we can use this meter rule or a meter scale to know from what is the height from which we drop this metal sphere. And we can use, we have the equation of the motion S is equals to ut plus half at square. So if initial velocity is 0, this whole factor will be 0. So S is equals to half gt square. Means the height is equals to 1 by 2 gt square. So S is equals to half gt square. Then what we'll do? We will plot a graph, like we'll change the height and record the time it will take using a camera, like the frames per second or number of captures, number of images per second multiplied by total number of images will get the total time. Like how many images in 1 second, then total images multiplied will be X. So we'll work out the time. So we'll drop this object from different heights, like we'll change the height, the time it will take to fall will also change. We'll plot a graph on y-axis. On y-axis, if I have height, and on x-axis I have t square. So the grade, it will be a straight line because it's half g. So the gradient of this line will be equal to g by 2. So if I need a gravity expression due to gravity, so it will be twice of the gradient. So we'll measure the distance with the meter rule, and we will use the images per second of this camera to work out, like the number of images multiplied by the frames will get the total time. Then we'll plot a graph between the like we'll change the height, we'll repeat the experiment with different height and record the time. Then plot a graph between height on y-axis and time square on x-axis. So gradient will be equal to half g, or g is equals to twice of gradient. So these are the points you should mention to work out acceleration of a free fall. So sometime we may have a stopwatch, sometime we may have a camera here, or light sensors, light gauge can also be used. Describe systematic error. So what is the systematic errors? So, or what are the systematic errors? We just have to mention, describe a systematic error which could arise in this experiment. So what are the possibilities? Systematic error means like error in the system. Random is due to sudden change in environment. So what is one possibility? Maybe the scale or the meter rule which we place may not be exactly vertical. Yes, you can mention, but alone parallax error is not sufficient. If you just mention parallax error, that's not sufficient, because you should mention that the parallax error from the camera to object is there. Like the position of the camera is not exactly vertical uh, or in line, so we are not able to record its image. Maybe what might happen, like we place a camera in this manner. So when we place a camera in this manner, what is the possibility that this position may not be uh, there in the first image? And the second possibility is that maybe when we use this, when it is recording, like a camera is capturing the image, maybe the initial velocity is not zero, because the position of the camera is very important for this experiment. So when we place a camera, the position of the camera is very important. Even, for example, it is exactly vertical, perpendicular to the scale, but the ball is at this position, but the camera is not able to capture this region. So when the ball will enter, this ball will have some initial velocity, because we are considering initial velocity zero. But when the camera is capturing that, the camera is capturing only this region, the image. So it may not have a zero vertical, it may not have a zero velocity, like initial velocity zero. So that is another possibility or source of error, systematic error. So what are the possibility? Maybe the ball which is released, the first image, the initial velocity may not be zero, or the scale or the ruler is not exactly vertical, or camera is not calibrated correctly. That is also a possibility. Like calibration of the camera is also important. Then the parallax error from camera to the object. That is also another possibility. But don't say a lone parallax error. That is not correct. Then describe one property of a steel ball that make it suitable to use in this experiment and why this property make it suitable. First thing, steel ball will have relatively high density. So when an object is having a high density, means it will have more mass in a small space. Otherwise, like example, if I use say a plastic ball, so plastic is having low density, so same mass will have a large volume. So what will the advantage of using a steel over the plastic? This steel ball is small, so it will have a small surface area, so it will experience less air resistance. So it will not reach a terminal velocity. But if you use a plastic ball, then it have a large surface area, more air resistance, so it will reach a terminal velocity. We don't want it to reach a terminal velocity as we want to find the acceleration due to gravity. So you can mention like steel, it's dense object, so it will have like in a small space will have a large greater mass. So small surface area which reduce the air resistance, so less likely it will reach a terminal velocity. Then explain an advantage of using a video camera to make measurement for this rather than a stopwatch. So when you compare, like example, in a video camera, there is no reaction time. So it reduces uncertainty or more precisely measure. The video camera can be paused or stopped to take reading in between, and measurement it exactly measure the times, and we can change its position or orientation with reference to the meter rule, and it allow us to repeat the experiment or playback or rewind, so we can confirm the values. So values will be more reliable. These are some few advantages related to using a video camera over the stopwatch. Then the last question is also similar. Explain the advantages of using a digital video camera uh, compared with a rule and stopwatch to obtain the data to find acceleration due to gravity. So it's more like you better memorize these parts. Whenever you're using a video camera, there is no reaction time, first thing. Then second thing, it can be paused or playback anytime. We can take more readings in a given time, reduce the uncertainty, allow the values to be checked. Even you can zoom in to the reading of a meter rule. So better memorize these advantages and the reason for that. So if you mention no reaction time, explanation should be that it reduces the uncertainties, then can be paused or stopped to take reading. So measurement take at exact times or position against the rule recorded more accurately, and allow repeat or playback so the values can be checked or confirmed. Then multiple choice question 17. In this question, an object of mass 8.2 kilogram, which is initially at rest, so initial velocity is 0. It fall vertically, so that is a distance. The final velocity is 20. Which of the following gives the energy in joules dissipated by air? Like how much energy is being lost? So what happened initially? It will have a potential energy. just before it hits, it will have a kinetic energy. So how much difference in the potential and kinetic energy, that is how much work is done against the air resistance or how much energy is dissipated or lost. So basically the potential energy minus the kinetic energy. Potential energy is mgh and kinetic energy is half mv square, which is 0.5 mv square. So mass is given 8.2, gravity is 9.81, and the height from which it is dropped, that is 25, minus half the mass is 8.2, and the speed at which it was moving just before hitting, that is 20. So it will be 20 square. So 8.2 into 9.81 into 25 minus 0.5 into 8.2 into 20 square. So option C will be the valid answer, that this gave us how much work will be done against the air resistance or energy dissipated or lost in the atmosphere. So this was SI quantities, graphs, and motion assignment doubts.